Shocks and Springs on a Car and Track by Jeremy Odehall, Alif Parsal, Desmond Lee, and Casey Bob. Video narrated by Jeremy Odehall. Our goal is to show the different types of shock absorbers and the different types of springs on the vehicles and how they work together in 4 real-world examples. What is a shock absorber? A shock absorber is a mechanical or hydraulic mechanism that absorbs and dampens the shock impulses from the road. It takes the kinetic energy from the shock impulses and turns it into heat energy, which is then later dispersed out. The main job of a shock absorber is to keep the vehicle planted on the ground, so the vehicle can retain its friction on the road in order to move the vehicle along. Shock absorbers disperse the heat by 3 means: hydraulic fluid, air, and electromagnetic cylinders. The different types of cylinders are twin-tube cylinders and monotube cylinders. For twin-tube cylinders, the piston moves the fluid between 2 chambers, which is then heated up and disperses the heat evenly. Monotube cylinders is a free piston that separates the oil and gas chamber. The advantages of a twin-tube cylinders are: external damage does not affect the absorber, cheaper than a monotube, and has a more comfortable ride, and has less stress on the seals. But the disadvantages of a twin-tube cylinders are: they are difficult to install because they have to have a set angle for installation, aeration is possible causing cavitation, smaller piston size, and less oil capacity, taking longer to cool, which can reduce resistance in the next bump. Advantages of a monotube are: they can be installed at any angle, large oil capacity, which means greater heat dissipation and less likely for cavitation. Disadvantages of monotubes are: stiffer ride, higher amount of wear on the seals, more expensive, and external damage can affect the cylinder. Shock absorbers are not the only thing that helps the vehicle with road changes. Springs also help transfer and absorb the energy, while the shock absorbers helps dampen the movement of the springs. Without the shock absorbers, the vehicles would bounce up and down until the car ran out of kinetic energy. The 3 different types of springs on a vehicle are leaf springs, coil springs, and torsion bar. Leaf springs are usually found in the back on the rear wheels of trucks and older muscle cars. Coil springs are found in the majority of newer cars, while torsion bar springs are found in older vehicles. Advantages of leaf springs are: they are simple to set up, they spread out the weight evenly, while the disadvantages of leaf springs are: compared to coil springs, they are uncomfortable ride and much louder. Coil springs have the most flexibility and are better for low riding cars. While they have less weight capabilities, to save weight they are made much lighter and thinner. Torsion bar springs can take up less volumes, the ride height can be changed to the user's liking, but are more likely to be damaged from the road. For the springs, it is good to find a ratio between soft and hardness of the springs. The softer the springs, the quicker the car goes around the bumps. While softer springs are good for rougher roads, they can also cause the car to bottom out, which can cause damage to the undercarriage of the vehicle. On the other hand, harder springs help prevent the springs from bottoming out, but too much spring stiffness causes the car to bounce in the air, creating less traction on the road and reduces the vehicle's speed. The following 2 videos show the same car bounce to the same area. The first car has 0 spring stiffness and the second car has max spring stiffness. Notice how the car bounces as it hits the bumps. The movement of springs from neutral position to the max height is called travel time. The rougher the road, the more travel time the vehicle needs. Common street cars, the cars you see every day on the street, have the longest spring times and can handle a large range of street conditions. High-performance sports cars, like race cars and exotic cars, have less travel time, which makes them limited to certain road grades. Sports cars, such as muscle cars and sports sedans, have better suspension than a common car, which makes for a smoother ride, but can handle the same roads as common cars. This makes them the best of both worlds between a common car and a high-performance car. The next slide shows a picture of the mixed ratio between soft and hard springs compression for our simulation. Notice the front springs and the rear spring number. Our first video shows these spring numbers shown on the track. Next 3 videos has the same car going around the same track, but with 3 different spring forces. First video has the car with the previous numbers before, second video has 0 spring force, and the third video has max spring force. As you watch the 3 videos, notice how the springs bounce up and down as the car goes from brick road to paved road. Notice how when the car takes the turns, the weight of the spring also changes. As the car turns left, there's more weight applied to the left side. This is vice versa as the car turns right. In the last video, notice how the springs go up and down more violently than the other 2 springs. At the end, it is important for the car's spring and dampers to work together to provide excellent control of the vehicle. Good spring rate. This shows the math problem that represents the force applied to the springs due to the mass of the car. The variables shown are B for the damper element, K for the spring constant, M is the mass of the vehicle, and X dot is the vertical displacement of the springs. Shown here is the math problem of the car in Laplace transformation. Y is the top of the car and U is the ground. Here we have the input math for our Nissan Frontier. The mass is 4,154 pounds, X dot is 33 inches, and regular X is 8.5 inches, which is the length of the spring at natural position. For this instance, all 4 wheels have the same height, and we're neglecting the mass of the wheels and the wheel stiffness. Here we're doing the same thing as we did with the Nissan Frontier. Now we're doing it with the Mitsubishi Outlander, Chrysler Crossfire, and a Hyundai Santa Fe. In conclusion, we learned about different springs and shocks on vehicles, and what they look like when the spring stiffness is changed, and math for 4 different vehicles. Here's a list of all the sites we used for our work. All simulations were done in Forza Horizon 3 and Forza Motorsport 7. Please like, comment, and subscribe for more tips and tricks.